Okay, so if we take a look at this problem, we're working with molarity again. And so I think one of the best ways to start this problem is just to start off with the numbers that we have. And then after that, we can see what we're looking for, okay? So it's asking us how many grams of LiOH do we need to produce a 150 mil of a 0.3 molarity LiOH solution. Okay, so a couple things we can already get right off the bat. What are we looking for in this problem? Yeah, we want to find grams. Okay, so this is what we want to end up with. So this is kind of our end point. Okay. Now we have some numbers to work with. The first thing that we have is 150 milliliters. So that's going to be our volume. So our volume is equal to 150 milliliters. Now, if you guys remember from last time, if you ever have milliliters, we need to turn it into liters. So we can do that very easily by dividing the number by 1,000. So you can divide 150 milliliters by 1,000, and that should give you 0.15 liters. Okay. So whenever we're working with molarity, and you're trying to find molarity or anything like that, just make sure you turn milliliters into liters. Very simple, just divide by 1,000. Okay. All right, and then the last number that we have is going to be our value for molarity, the concentration. It's going to be 0.3 molarity. Okay, so those are all the numbers that we have in the problem, and we just got to use all of that in order to find grams. Okay. Okay, so since we have molarity and liters, it means we're probably going to be using this equation right here, right? We got capital M and we got liters, which means that we can find moles. Okay, so I'm just going to jot down my equation right here just so that we can work with it. So molarity is equal to moles divided by liters. And what we can do is we can just plug our numbers in. So we got 0.3 molarity, so we can plug in 0.3 molarity. And then for our volume, we got 0.15 liters. So I'm going to plug that in right there. Sorry, let me just put it on the side a little. So 0.3 molarity. And then we got moles divided by 0.15 liters. Okay. So I'll pause right there for now. Any questions on how we plugged it into the equation, or so far so good? Okay. All right, so we have molarity in liters and we want to find moles, because if we ever want to find grams, easiest way is just turn moles into grams, right? And so what we're going to do is we're going to isolate the moles. So just think of this as regular algebra. Let's just pretend this isn't moles. If it's x, how can you isolate x in this equation? Yeah, you just multiply that by the denominator on both sides, right? So we're going to multiply by 0.15 on both sides, because if we do that, these can cancel out, so they disappear. And then all we have left is x, or we substituted that for moles. So we just have moles by itself on one side. Okay. So it's just basic algebra. You're just isolating for one variable. And then from there, you can just do 0.15 times 0.3, and that will give you 0.045. And that's going to be our moles. Okay. All right, so we just need to turn this. This is our value for moles, and we just need to turn that into grams now. Okay, so whenever we want to go from grams to moles or moles to grams, the value that we need for our fraction is going to come from the molar mass. Okay, so we're going to go to the periodic table. We are going to find the molar mass of Li, O, and H, and then that should give us the numbers to the fraction. So I'll give you guys maybe about a minute and a half. See if you guys can find the molar mass of the chemical we're working with, LiOH, and then see if you guys can plug it into this fraction correctly, okay? You're going to have to put grams on and moles on either the top or bottom. See if you guys can put those in, and get the final answer. So I'll give you guys about a minute and a half to try finishing that up on your own. Again, you're going to find the molar mass of LiOH. Okay, so the chemical we're working with is LiOH. So we're just going to go on the periodic table and add up LiO and H. So if we look for Li on the periodic table, Li is going to have a molar mass of 6.94. We got O, which is going to be 16. So we'll add 16 to that, plus 16. And then we got H, which is 1. So you're just going to add 1 to that. Okay, so you should get a final molar mass of 23.94. Everybody good with that? Yes? Too early for math? Okay. 23.94. So the molar mass of LiOH is going to be 23.94 grams per mole. Now, we got to put it into this fraction correctly. So since we have moles on the top, we're going to put moles on the bottom to get rid of it. So it's going to be 1 mole on the bottom. And then we're going to put grams on the top. So 23.94 grams on top. The moles cancel out. And then from there, we just plug it into the calculator. Just plug in 0.045 times 23.94. And so our final answer is going to be 1.07. And we can just leave it at the 7. Okay. So 1.07 grams of LiOH. If you rounded that up to 1.08, that's totally fine. Anything close to this value is all right. Okay. Okay, so before we move on, what I want you guys to do is I want you guys to put a box around these 3 numbers. Okay, the first one I want you to box is the final answer, which is the grams. So this is going to be the mass of solute. I want you guys to label this as your mass of solute. Okay, so today what I'm going to be teaching you is how to write procedures in the lab for making these solutions. So next time we meet, you will be practicing making certain chemical solutions. And today I'm going to show you guys how to write the steps for that. That way you guys know what to do. Okay. All right. Next, we're going to put a box around. Let's put a box around both of these. Okay. 150 milliliters and 0.15 liters. And this is going to be our volume. Okay. Actually, let's label that as final volume. Okay. This is how big your solution is going to be. Okay, and then the last number that we're going to box is going to be 0.3 molarity, and we're going to label this as our concentration. Okay, so when you guys are making these solutions in our labs, these are the 3 things that you're going to have to know about the solution. First of all, how big the solution is, right? How much of the solution you're making, how strong the solution is or the concentration, and then how much solute you need to add in order to make that solution. Okay. So those are the 3 things that you'll need to label. And I'm going to show you guys how to write the actual procedures, and then that'll be it for today. Okay, so let's get into the actual procedure writing. Does anyone still need a little more time to copy this down? Okay, let's move on. Okay, so your procedures are going to come in 5 steps. And so let's jot these down. The first thing you want to do is step 1, for any time you make solutions, you're going to want to get a volumetric size, that volumetric flask, which is the appropriate size. Okay. So step 1, you're going to get a volumetric flask. That's the appropriate size. And I'll show you guys what a volumetric flask is in just a second. Okay, but you want to get a volumetric flask with the appropriate size. Okay, so we're gonna use the warm-up problem as our example here. So if you guys take a look back at the numbers that we worked with, how big is our solution gonna be for that problem? What's the volume of our solution in the warm-up? Yeah, 0.5 liters or 150 milliliters, okay? So what this means is basically you just want to find a volumetric flask. The volumetric flask looks like this. Okay, you're just gonna find a volumetric flask that has the size of the solution that you want. So for step one, let's write this down. Okay, so for your procedures, if you're making this solution right here, what you're gonna do is you're gonna obtain a 150 milliliter, and we can abbreviate it volumetric flask. Okay, that's step one. Super easy. You just need to make sure that you get a volumetric flask that is the volume of the solution that you want to make. So that's step one. Okay, step two, you want to weigh out the mass of the solute that you need. Okay, so you want to go to a scale, obviously, and then you're going to weigh out however much of the chemical that you need in order to make your solution. Okay, and this is the number that we calculated out just now. Okay, so if you take a look back at the warm-up problem, how much of the solute did we need in order to make the solution? What's the grams of solute that we found? Yeah, 1.07, right? So we're gonna say just write weigh out 1.07 grams of LiOH, the chemical we're working with, on a scale. Okay, so that's going to be step two. And whenever we make these solutions in class, and you'll have to write the procedures for when you guys do the experiments, it's always going to be the same 5 steps. Okay. So far, so good. Okay, the last ones are pretty easy. The third step, you're going to add the solute to the volumetric flask. So you can just write that down, and we can literally just use that as step 3. We're just going to add one thing onto it, and then we're going to using a funnel. Okay, that way we don't lose any of our solute as we're transferring it into the volumetric flask. Because if you guys can tell, the opening is very narrow for this. Okay. All right, and then for step 4, what we're gonna do is we're gonna add this solvent to the volume, to the final volume. So basically, what this means, and in this class, we're gonna be using water. So we can just write add water until it reaches the line. Okay, so I'm gonna pass the volumetric flask so that you guys can see it. But there's a line on the narrow part of the flask, and that tells you that you filled it to the final volume that you want. So the one I'm going to pass around is 250 mil. And then once you fill it up to water until that line, that's going to tell you that it's the solution's at 250 mil. So I'll pass it around so you guys can take a look at what the line looks like. You guys can't see it up here. Okay, but basically you're going to first add your solute, and then you're going to fill it up with water until it reaches that line. Okay. All right. Now, one thing I do want to mention before we move on is you are always, okay, and this is very important, you're going to always add the solute, okay, before water. Okay. This is very, very important. You're always going to add the solute before you add the water until the line. Okay. Okay. And the reason why this is important is because let's say we fill it up with the solution to the line, and then we add the solute. What happens if you add stuff into a liquid? What happens to the water level? Yeah, it's gonna go up. And then what if the water goes past the line? You're no longer at the final volume that you want, right? That's the reason why you always want to add the solute first. It's because if you add the solute second, then the solution gets bigger, and then you're not going to have the concentration that you want, and that'll mess up your calculation. So always make sure that you add the solute before you add the water, okay? All right, and then last step, you're just going to stir until homogeneous, basically until everything gets dissolved. Okay. And that's it. Those are the 5 steps that you're going to be using in order to make your solutions. Make sure you guys have those jotted down. This will be posted on Canvas for you guys to refer back to, because the next time that we meet, you're going to be actually making solutions, and I'm going to have you guys write the procedures for me before you guys actually make it. Okay. All right, and that's pretty much it. Any questions? Okay, so for today, pretty simple. What you're going to be doing is you're going to be finishing up the assignment from last time if you guys didn't do that already. I know it was kind of a longer assignment, but there is a new assignment, but it is pretty short. It's only 3 questions, and it's going to involve writing procedures. So just make sure that you guys finish up the new assignment for today if you guys finish the one from last time. Okay, other than that, I'll give you the rest of the class period to work. Let me know if you have any questions or if you guys want to check the answer key.